Good morning and good afternoon to all. I hope you are doing good and welcome back to the second part of this tutorial. So in this tutorial, we are going to learn about how to consume SQS queue item and put it in Dynamo DB table. So just a short recap. In the first part, we have seen how to create a SQS queue item using Spring Boot app. And why we are using SQS here? Because SQS does not have a strong ordering guarantee, nor it is intended to be used as storage item like Apache Kafka. So in this uh, uh, our application, we do not have such requirements. So that is the reason we are using SQS queue. So let's get started. So why in the we have seen in the first part here. So we are using Dynamo DB based scheduler. So why Dynamo DB? It's because Dynamo DB is based on the concept of B tree, which gives the possibility to scale our application with high volumes. In our design, scaling is our first class citizen. So whatever we do, it's should be scalable. So you might know that quad scheduler also available, which can also be used as scheduling purposes. But the problem with quad scheduler is that it does not scale well when there are many requests coming in. We could also, you can also think that we can also use multiple instances of MySQL server along with Quad Scheduler. But the problem is that it's not a very cost-effective solution. So DynamoDB is cheaper than the MySQL based solution. And DynamoDB supports a partition key and a sort key, which exactly maps to the random ID and the scheduled time of for the each job. And we will see how it is done shortly. Because DynamoDB is implemented using B trees internally, and therefore range queries on short key are highly efficient. Because we use a random ID as partition key, so our read-write load is evenly distributed across all partitions. So this is all theory. So let's understand how this concept using a diagram. So this is the uh, diagram which we are going to follow. And let's say we are creating a shards which has a range between 10 to 1024. So on the left hand side is a DynamoDB based table and this is a Kubernetes cluster. So this Kubernetes cluster we'll talk about in the next video. So in this video we are going to learn about this sharding concept. So when we create an item in the DynamoDB, it has three columns. One is shard ID, date token, and job status. So shard ID is not a unique, but it is a partition key. Yeah. So as we discussed, the shard ID is a partition key, and date token is a short key. Okay. So this shard ID is divided into three parts, and each part is processed by respective pods in Kubernetes cluster. And why it is done so? Because each pod will have their respective ranges. So first pod 1 will have 1 to 341 and pod 2 will have 342 to 682 and so on. And this is because this each pod is responsible to process the request evenly. So it is not like that each pod will be responsible for more number of requests and another pod will be sitting idle, something like this. Okay. So just for a high level, so just think about like this, that each pod is evenly distributed to process the each requests. So that it does not basically put a load on the system for each and every pod. Yeah. So now as you see here, this shard ID 50, it falls under pod 1. So somewhere here, right? So pod 1 will be responsible for the processing of this item. Similarly, pod 2 will be responsible for the second item 430, so and so on. And uh, and uh, now this date token also has two parts. So first part here you see it is time, Unix time, when it is supposed to be run, and second part is the unique identifier for each and every job item. So yeah, so shard ID is a partition key which is not an unique. It multiple job can have same sort ID, and the date token which is actually unique. Yeah, and this reason is done because this the partition key, and because of this range queries which DynamoDB actually supports. Okay, and also you can have one more column here. For example, you can have a job metadata here, but for this tutorial I'm not using it, so you can have as much column as you want. All right, so I hope it is clear. So now we have to write some code to consume it and then put it into DynamoDB table. So let's get started. So I'll create a class here, and I will name the class as SQS application. So yeah, and then we are going to create some credentials here. So first, yeah, I'll explain. I'm just copy pasting because of this to shut because of the time constant. So this SQS client is actually which I have written previously, right? So if you remember, so this is the SQS client which I am using. Yeah, and yeah, and this is a job object mapper and all these things here. Let us let us this import everything constants dot key dot secret. Okay, and now what we are going to do here is we are going to create a void main. Do not need this. Okay, and then we are going to define this function here. You need to define this function here. Okay, so here let us import and everything. Okay, and then okay, so we are also going to need this DB client here because this is what we have to use for DynamoDB based table. And I'm using US East 1 region. Yeah. So this is all done. So and now we are going to define this attribute map. And this is the attribute map where we actually map these requests. And this is my table. My test DB is the table name, and we are going to define the different parameters for this table. Okay. All right. Okay, so still what it is complaining here. Okay, so I have to add throws statement here. Throws. All right, cool. So now all the errors has gone. So let us recap what we are doing here. So first I'm going to create asynchronous client to consume the queue item from this queue and then iterating it. And after iterating it, then uh, I'm getting the date token, and then I'm passing this to this function, and this function is basically uh, creating the item which is required for the DynamoDB to be inserted into this, to all the information to be inserted in the DynamoDB table. So all good. So right now let us see that I have this table already created here. So here you can see this is the table here. I do not have any item here, so they have created this table before. And now let us run this job. What do you guess? It will work? Okay, so right now there are no items here. As you see here, there are no items. So now let us see SQS. Yeah, we'll go to SQS and we'll see there are five queue items are here. Okay, and it should be processed and then it is going to be inserted here. So let us wait for a couple of minutes here. So I think it will work. Finger crossed. I hope it will work. What do you think? Hmm, Let us make it a little bit larger. So I have a sleep of this. Okay, and it has run again after the sleep. And here we go. So here we have a new item here, 98 shard ID. Yeah. So now it is scheduled, and this is the time, date token, and this unique ID here. All right, so as you can see here, as per this diagram, here this pod 1 supposed to be processed. Pod 1 supposed to process this item from this shard ID, and then it will consume it, and then it will run it accordingly. So I hope you have got the idea how this sharding is working. So and in the next video, we are going to see how pod is actually consuming it from the DynamoDB table. And so see you soon. Take care. Bye bye.